Hello everyone, got a quick stream today. I wanted to follow up from my previous video where I talked about doing press fitting of nuts with a soldering iron. Turns out that that's not quite possible. So, since the parts that I ordered are not correct. So, we're going to change it up. I got some M2 screws, very small little things, but the head of the screw, if you can even see that, yeah, cool. The head of the screw is big enough that we can use it to mount all these pieces. So that's what we're going to do. Specifically mount the Raspberry Pi and the screen. And I think I might actually try and make some little spacers in 3D print some spacers as well that'll sit right, so the screw will come in this side, put a little spacer right there where that little ring is on that side. That'll give us a little bit more gripping power on the screen so it doesn't move about. So let's jump in and do that. Cool. So if I recall, let's see, the holes here, let's bring up our tools. Cool. Okay. So I want to measure. This is a little hard to look at. Here, to the center of that is 4.5 millimeters. Okay. Which means we should want to come up 4.5 millimeters from this surface and draw a circle on here. And this little yellow marker will give us a center line from where to do a vertical. And I want to make this 4.5 millimeters up. Cool. I'm going to get out my calipers and measure. Actually, let's just pull up the internet real quick. M2. So I always like to grab the screw dimensions just to do a little sanity check. And let's see if this is M2. So M2s, so we're looking for the D diameter of an M2. I believe M2 actually just means, oh man, 2 millimeters, right? DK. Okay, so I'm eyeballing this that roughly, yeah, I believe, oh man, why am I spacing out on this? Metric screws. Okay, I'm going to get out my calipers to double check. Okay, so one of these screws is, outer diameter is, yeah, is about 2 millimeters. Awesome. Thank you for the follow, Jed. So if the outer screw is 2 millimeters, we're going to want to make the inside here a little less. We want some, basically we want the hole to be smaller than the screw so that when you screw it in, it gets stuck in there. But we don't want it so small that the screw actually pushes the material out and this little bit cracks, because then we'd have to print this all over again. So the way to actually pick that diameter, so I luckily have a power drill, and so I can experiment with this. But if you didn't have a power drill, maybe just do some test prints, use the screws, and then go from there. So I'm going to actually just make it real small. I'm starting to learn things about 3D printing, so I'm not sure if this is actually true necessarily for circles, but I know that in your 3D slicer tool, the tool that goes from like this CAD model to your 3D printer, you can specify the thickness of the print, like as the 3D printer is moving around, you can specify the thickness of the filament as it comes out of the extruder. And if you do it in multiples of that number, things should fit. That actually doesn't make any sense. I take that back. Let's go half a millimeter. Whoa, that's small. If my screw is 2 millimeters on the outside, let's try 1. Cool. Okay. That is the diameter, right? Yeah. So 1 millimeter. Wow, why does that look so small? I guess these screws are really small. Okay, so we're going to want to repeat this pattern on all 4 of these faces. So we'll do a little rectangle. We're going to want the center point right there to be coincident. Or no, not coincident with the line. We want it. Oh, yes, we do. Coincident with the line, which means now when the line is stuck relative to that point. And then we can do our dimension from here, which I believe was 4.5. If I can select, there we go, perfect. Cool. The black lines mean we can now, everything is fully defined and not ambiguous. So I can select these 4, turn them to construction because we don't need them as part of this. We just want to get the 4 corners, and then we can draw 4 circles. Or 3 circles, I should say, since we already have 1. And the circle tool is perfect. And 1 more. Ah, okay, cool. And then if we make all 4 circles equal, we are done. Okay. So let's extrude these out. Cut little holes. We're probably not going to want to go all the way through because we don't want this on the yeah, that's way too far. So we're going to want this Hey, sorry, Jed. I was having some issues with my chat. The screen is, let's see. If I take the ruler, side length is 12 millimeters by 7 millimeters. I will be posting a parts list on Hackaday once I'm done of everything that I used to make this project. But I believe, let's see, I think it's the 5-inch HDMI display for the Raspberry Pi. I believe it was not quite this guy, but something similar. Actually, I can just bring up my order history real quick. Oh, here we go. Okay. So it's this guy. The Elecro 5-inch capacitive touchscreen for $50 off of Amazon. I've enjoyed it. It's a little hard to figure out where your finger is. So trying to just use your finger as a mouse to like click on the things on the screen here is a little bit difficult. But for the most part, I'm trying not to use this as I'm not going to interact with the screen too much, I think. I might put some like large buttons on it or something, which will make it really easy to tap them. Some like digital buttons, like on a web page that you can tap. Yep, and then you just connect an HDMI and USB cable, and you're good to go. Cool. Okay, so we're going to make this up to the surface here. Yeah, perfect, which means you won't be able to see it on the front, and that's what we need. Perfect. So now we have 4 little starter holes. I suspect I'm gonna have a little bit of trouble 3D printing those, but at least they'll kind of give me a starting point to drill um, if I need to make the holes larger. Bear with me 1 second. I don't have Twitch chat up. Cool. Okay. All right, so let's now go back to our assembly. Let's double check that these holes all make sense. So that definitely makes sense. That makes sense. Perfect. I want to double check all these things before you spend several hours printing. That's always annoying. Okay, cool. And then we're going to want to do the back plate and do the same thing. And I know that from yesterday, once I can open up the sketch, these 4 holes are exactly, there's a rectangle that defines these 4 holes. And if I go exactly at the center of that rectangle, I'll get the cut that I need, or the holes that I need. So, do a little sketch on here to make this one visible, and then I can use those 4 holes as reference points. And I don't even have to really do another sketch. Oh no. Hole tool's having a little bit of trouble today. There we go, cool. So again, we'll make these all equal. Set their diameter to 0.5 millimeter. Do an extruded cut up to a specified surface, which is right there, which is what we want. Oop. I'm going to change the view to, yeah, okay. It's the see-through view, and we can see that it's actually going up to the next surface, which is what we want. And we will double check those holes actually make sense, and they do. Cool. All right, I think that's the one modification I wanted to make today. I'm going to peek these screws, though. I make sure I want to make sure I actually have a screw that I can use in this project. So this screw will go 6 millimeters deep, and we'll measure. I think this height's actually 6 exactly. Oh no, it's 4, isn't it? It is 4. Darn. Okay. So I know that one's 4. That one's also 4. Okay. Oh, and then we got to account for the thickness of the board. Let's try that again. So we want from this surface down to, I guess, where this line is. And that gives us, oh, this is hard to see. Which line do we want? We want the purple line, which is 5.33 millimeters. Okay. And down here, from here to here, it's 5.5 millimeters. All right, so we're going to want spacers, because otherwise, if we don't have spacers, my shortest screw that I do have in this little bin, it's actually going to pop right out through the case, and that'll be kind of ugly, because we want a nice little case on the outside. So, let's make some spacers. So we're going to need 2 different spacers, one for the Raspberry Pi and one for the screen. No idea how to dimension spacers. I'm going to assume that the inner diameter is about as big as the screw. And the other one will make sure it doesn't conflict with anything. So basically, I look at on here, if I just measure the distance across, we want it no bigger than 8 millimeters. And then if we look at the Raspberry Pi, we want it no bigger than 5 millimeters. So I'm basically just looking at this little, down here, this little hole right here, and making sure that it doesn't conflict with any other components on the board. So that, double check that diameter, because I'm just going to use this for both, actually make this simpler. We go 5 millimeters outer diameter. Cool. And there is our spacer without a dimension, or without a depth. So if we make those, I should have written those numbers down before, but I didn't. So from this line to this line, oh, this is easier actually, 5.3. So if we make that 0.7, 0.7 in height should be good. So 0.7, and then it was 0.5 for the other one. I can't select any lines here. There we go. So that height is 5 points. Okay, so 0.5 and 0.7. Cool. You know, if we just make this 0.7 for all of them, this should be also fine. And then I'll have to print one part, print and maintain one part. And engineers are lazy. Did you design the PCB as well? No, the PCB is a Raspberry Pi. And that's the only two components that I have. The HDMI screen comes with a board attached, and sorry, I'm just getting at Jeff, or Jed, sorry, your question. Yeah, both of them just off-the-shelf components. And then everything else is like cabling, like an HDMI cable, a power cable, a USB cable, all also bought off the shelf. Cool. All right, so we'll want to drop this in. And then make this surface stick to this guy. Cool. I'm not going to do the full assembly, but just to see how that looks. And I think that looks good. And then we're going to want to drop in one more of those. Cool. And stick it in right here. Oops, gotta meet. All right, perfect. And then this surface. Oh gosh. And that surface. Oh, perfect. That wasn't that hard as I thought it was going to be. Okay, so want to bring in a lovely little tool to show the cross section. Nope, not that side. Cool. So I can drag this guy along just to see how those holes actually look. It's right here. Cool. So now I can come in here and look. That looks good. I hope this makes sense. I don't know why I feel like I'm always confused by washers, spacers, that kind of thing. They seem so simple. But that should work. I believe that should work. Doesn't look like it conflicts with anything. Adds a nice little bit of height. And then if we move this over to our other one, and check how this looks. Oh, let's move that out a little bit. I want to see the hole all the way through. If it'll let me move it, it's struggling. Oh, sorry, Jed. No, I grabbed it. I think off of Thingiverse. Thingiverse, GrabCAD. Do you know about Thingiverse or GrabCAD? Because here, I'll just bring it up real quick. So we have GrabCAD and Thingiverse, two sites that I enjoy. So you can come here. Where's the search bar? I usually find this page through Google when I'm searching for things. Okay, interesting. Let's see, so I think I clicked on this one. Yes. So this is the one that I used. So you can come over here, you can download the files. It will give you. So I am using SolidWorks, and they give you SolidWorks part files that you can download, and you can actually edit them. Also STLs for other software. I know that I think Fusion 360 you can drag in STL files and work with them. Oh, cool. Awesome. Yeah, I am lazy, so when I can get away with not having to redesign things from scratch, I try and do that. So yeah, you can do them here. And Thingiverse also has stuff. This is also like 3D printed or things that you can print out if you have a 3D printer that other people have designed. My files will eventually find their way here as well. Cool. All right. So I think that's all I wanted to do for the night. I did start, I forgot, a Hackaday project. So links down in the description. And the project is listed here, Raspberry Pi Smart Display. If you're watching this later on YouTube, you can follow the link down in the description. And so not much here, but a placeholder for this project. I will be posting all of the files, a parts list, things like that. And I think this will hopefully actually be my last stream because I'd like to, fingers crossed, print the back case, back cover, front case, screw it together, and just be done. And hopefully that's it. That's not really worth another stream. And then I'll just post photos here as well of it completed. Might do another stream to write some code for it. So for those that didn't watch the first stream, this I built this before and I did it laser cut. And it used to show me the weather and when buses were coming so I could catch the next bus to work, but I don't get on a bus anymore to go to work. So this is what it used to look like. So that's a little web page there. You can turn Raspberry Pis in what's called Kiosk Mode, which I believe makes them kind of like kiosks that you'd find in the mall, or little like interactive displays that you don't really have to maintain. You just say, hey, open this web page when you start up, or do some other command. And so I think I'm going to set it up in Kiosk Mode, find something else to put on the screen. Could do photos, could do the weather. I don't really leave the house anymore. But yeah, this is what it ended up looking like. I left, I used to be in a makerspace, and I left, so I don't have access to a laser cutter anymore, but do have access to a 3D printer, so wanted to 3D print a case that I will find a use for. Because I'd like to start finishing projects instead of just leaving them all half finished. So, expect maybe one more update or a live coding kind of session, TBD. And with that, I will end the stream. Generally stream on Tuesday nights, been thinking about when to stream on other nights. Tuesday nights I've been putting together kind of a long series project of putting together a 2D plotter. So the current state of that is I just ordered parts. And I'm waiting for them to arrive. I did a whole CAD model thing. I guess I don't have a current status of it, but this is kind of what it looks like. We got the motors all set up in there, some servos, some steppers, and some other things like that. So hopefully that'll arrive at some point in the near future. This week and next week I'll probably start writing some code and tinkering with the 3D printed parts. So if you have time, stop by. And then hopefully doing another night where we learn about new things and create wacky side projects, all as one-offs, one Twitch stream, maybe on a Wednesday or Thursday, TBD. So, done rambling. Thanks y'all for joining. Thanks Jed for the questions, and I will see y'all next time.